Okay, everybody. Welcome back for yet another talk. This time we have Dom with us from the company with a nice name, Paren, and yes, they have parens outside of it. He will introduce GraphQL to us, so all the people having a REST API, prepare for the next rewrite. It's going to be GraphQL, I guess. And in the announcement or the abstract of his talk, he said that JS is going to be simpler than ClojureScript. However that may be. Please give a big warm applause to Dom Kiva-Meyer.
Hello, everyone. My name is Dom. My partner and I have a small Clojure consultancy called Paren, and today we're going to talk about GraphQL. But first, we're going to talk a bit about Japan. See, I was in Tokyo a bit last month, and this is a picture I took from the 45th floor of the Tokyo Metropolitan Building. Tokyo is an incredibly huge city. It's literally a city as far as the eye can see. And everywhere I went, in every bathroom I went into, I found one of these. This is an electric toilet, and they are ubiquitous in Japan. Like, they're awesome, too. They have heated seats, they clean themselves, they clean you. They're futuristic, and they're everywhere. And I realized using GraphQL is a little bit like using a Japanese toilet. It's awesome, it's convenient, it's way better than the alternative, but it's still kind of crappy. So today we're going to be talking about GraphQL, and we're going to be talking about electric toilets. First, let's talk about some misconceptions, though. These are all things that I've heard in the Clojure community about GraphQL. I've heard people say, you know, Datomic is better. It's been doing what GraphQL has been doing for years. Why not just use Datomic? Or why not use SQL? Like, it's way more flexible. Everyone knows SQL. It's been around forever. Or I don't need a graph database. So these don't make sense. Mostly because GraphQL is poorly named, I think. It has nothing to do with databases. It is not a database anything. It is not related to your storage layer. It's just an API layer. So you can use it with any type of database or no database at all, just API. Facebook has something called Relay, which we'll talk about a bit. It has nodes and edges, so you might have seen that. That's not part of GraphQL. It's their own concept on top of it. So today we're going to be talking about GraphQL, and we're going to be talking about REST. They're similar in purpose, but I think a bit different in use. They both get the job, done, sort of. You might use them to solve similar problems, but the way you'll use them, I think, is going to be a bit different. And I think that you'll be a lot happier using the former. So what is GraphQL? In an application layer, GraphQL is the API, so like REST, but unlike REST, GraphQL has a specification. So GraphQL describes behavior, not implementation. There are GraphQL implementations in like every mainstream language, including Clojure. GraphQL describes, the GraphQL spec is just this. It describes a type system, a formal language for defining a schema, a formal language for operations, so that's queries, mutations, and subscriptions, rules for validating operations, and rules for executing those operations. That is all GraphQL is. That's all. So GraphQL is not perfect. I have a lot of complaints about it, and I will share some of them with you today. I don't want this to be a hype talk. Speaking of one of my complaints, I get so frustrated with technical talks because they make me so excited. I even made a graph. So like I have some problem, and it's not a big problem. I'm working on something. It's a little annoying, and I look for solutions, and I find some technical talk, and it's going to solve everything. It's awesome, right? And then I start using it, and it's not awesome. It is not awesome. And after I persevere, eventually I might get back up to here. It might be pretty good. It might solve a lot of my problems. It's not perfect, but it might be pretty good. So the goal of this talk is to get you through this graph by the end of the talk. No hype, just reality. First, most of this talk is going to be about the UI, but first we're going to have to talk about the server. Anyway, so let's talk about schema definition. This is the GraphQL's schema definition language. You see we have two types here. We have toilets and or brands and models, right? They both have names and they both have references to each other. You'll notice that this says type, and yes, these are types. Calm down. Regardless of how you feel about types in programming languages, I hope we can all agree that at system boundaries, types or specs or validations or whatever you want to call them are super useful. And that's exactly what GraphQL is. It is a very, very important system boundary. It's your API, right? So additionally, this type system is extensible, like EDN or transit. If you want a datetime type, no problem, you can add it. Whatever you want to do, you can extend it. It's also introspectable, which is incredibly useful. That means at runtime, clients can query the server, get back data about the API, understand the capabilities of the API, and then either do whatever they want based on that. And this is super useful for tooling. So next we'll have query definition. So this is what a client will do. A client will write a query. A query is basically just a nested map or tree where only the keys are provided. So in this case, we're querying for all the brands, just the names, and all the models, with their names of those brands. The server will respond, and it will look basically like the query, except that the values will also be there. In this case, we are saying we only have one brand, that's Toto, which is like a ginormous Japanese toilet manufacturer. And they only have one model, which is not true, but we're just aligning it for brevity here, which is the NeoRest 600, which, by the way, costs over $5,000, and I want one. Anyway, so that's the schema that tells clients what kind of queries, what kind of things they can do, and how things are related. But there's one big piece that we're not talking about, which is where does the data come from, and that's what resolvers are for. So a resolver is just a function. You give it some context, you give it arguments, you give it whatever the parent resolver returned, and it gives you that thing. So you have one resolver function for every field. Easy peasy. These are very, very useful. What it basically means is that you have an explicit API layer. So a lot of people will essentially just serve up their database tables if they're using Postgres or something like that. What having an explicit API layer does is it allows you to draw data easily from multiple sources, or change your backend without hurting clients, or add things to the API that you don't want in your database, like aggregate fields, reporting, complex things like that. So I think it's very useful. Anyway, so that's all we'll say about the server. Let's get back to the UI. So a GraphQL client does not have to use React, or doesn't have to be UI at all, right? Like you can have another server be a client. In this case, we're just going to be talking about UI. And we're also mostly going to be talking about React because React is declarative, and that works well with GraphQL. And I think most people here who've done UI stuff are going to be familiar with React at this point. So an important thing about building a UI is that you need to manage state. And part of managing state is having some sort of abstraction around that, like reframe, right? So with GraphQL, you can use it without any sort of framework, but I think it works well with two primary frameworks. One of those is Relay, which is from Facebook and is specific to React and React Native. The other is Apollo, which is from Meteor, and that works with React, Angular, iOS, Android, and a bunch of things. So today we're just going to be looking at Apollo. It's a lot easier to use than Relay. Okay, so first let's talk about collocation. Okay, so you don't put the toilet paper in another room or very far away. You try to remember to bring it with you. You co-locate it with the toilet, right? It's convenient. You co-locating toilets and toilet paper because to properly use the former, you need the latter. With REST, there's no easy way to declaratively state your data requirements and co-locate those declarations with UI components. With GraphQL, it's pretty easy. So first of all, pardon the JavaScript. I feel safe in assuming that most of you can mostly read this because unfortunately that is the world we live in. There isn't an open source Apollo 2 wrapper, and doing ClojureScript interop, while not too difficult with this, is going to make it more verbose, so we're just going to stick to JavaScript. One additional thing to note is that the GQL backtick thing, that's a ES6 template literal. It might look all syntax highlighty and nice, but it's actually just a string. So you can see here, we have a query, we have a component that is using that query and just gets the data directly. So you have your data requirements co-located with your actual UI components. So On the negative side of things, the query is just a string, and knowing that you're embedding raw strings in your code might fill you with a certain sense of frustration. At least it does for me. When I see this stuff, I want to replace it with data. I want like maps, I want sets, I want vectors, right? I want data there. There is a Clojure library to do this. However, I would counsel you to really try to stick with raw strings. They're useful for multiple reasons. So if you use HugsQL or something like that in Clojure, you sort of already understand like having raw strings that are in the native language have utility. They don't need to be relearned by other team members who don't know that language and have to learn a new DSL. They don't compile to some subset of the language and you actually want to target the whole language, right? They can also be copied into tools, so you can just like copy a GraphQL query into a tool, which we'll talk about a bit later as well. There are also tools that operate on whole code bases, right? So if you don't have the actual strings in your code base, you just have a DSL that compiles to those strings, those tools can't work on it, right? So there is utility in having raw strings there. I would recommend trying to stick with that. In terms of other GraphQL features and how they relate to electric toilets, I found this absolutely delightful video from Toto, that manufacturer I mentioned. So we're going to watch a few clips of it.
Take the toilet lids, for example. They open automatically when you approach the toilet. This mimics the Japanese taxi that automatically opens its doors for passengers, or the way employees of an establishment line up to greet customers with a deep bow.
Okay, so it senses what you want and it opens for you. With a normal toilet, your actions and your assumptions about the state of the toilet, aka the seat position, can differ. It can be up when you think it's down, vice versa. Things can get ugly. This is the case with REST. You have resources A, B, C. They have references to each other. You want to render something that depends on those things. You have to get your data in multiple chunks. You have to connect it. You have to deal with network failures, with server failures. You have like potentially dozens of partial loading states and partial failure states. Like it's a mess. It's really difficult to deal with, regardless of what kind of abstraction you have around that. And like an electric toilet will always open the lid for you before you need it, GraphQL will always load the data for you before you use it. So with GraphQL, the seat is never half open or in an unexpected state. You don't have partial loading. This is taken care of by the library. In this case, Apollo. So you either have your data, are loading your data, or you have an error. In this case, you can see if we're loading, we're going to render a loading div. If we're errored, then we're going to render an error div. Otherwise, we're going to render, the actual content. That's all, right? Now, this might be very exciting. I hope it's exciting because it vastly simplifies dealing with UI. So I'm just going to hop in here and be a buzzkill real quick because we need to talk about errors. When a normal toilet is broken, it's relatively easy to diagnose and fix, I would think. I'm not a plumber, but I would think that. When one of these electric toilets malfunctions, I'm going to go out on a limb and say that it's probably a lot more difficult to diagnose and fix. Similarly, all those nice things I said about the GraphQL type system do not apply to GraphQL errors. GraphQL specifies that you may return errors and that each error is represented as a map, and that each of those maps must have a message key. But that's all, basically. The structure is mostly undefined and untyped. So this is a completely valid GraphQL response. The errors do not convey meaning within the type system at all. They're essentially meaningless unless you have out-of-band communication between the clients, whoever they are, and the server, and like the API team, whoever they are. Like you have to have some other way than the API spec or than the schema to communicate, because you can't do that about errors. So REST is, it's a very much all or nothing thing. You request a thing, you either get it all back or you get none of it back, and you get one reason why it failed, if it failed, or if it succeeded, which is the status code. However, that's not how GraphQL works. Requests can be partially successful. Because of this, GraphQL servers typically just return 200 for everything, regardless of if there are any errors or however many errors there are, because there's not a one-to-one link between data and the number of queries. This means that common errors that basically everyone has to deal with, like authentication, server errors, validation errors, things like that, those are entirely left as an exercise to the developer. I think this is really unfortunate. It puts a big burden on developers. This really, I think, should be part of the GraphQL spec. It's a thing that you're going to have to deal with if you use GraphQL that is just sort of implicit within REST just because it relies on HTTP. Anyway, let's get back to our video.
When the lid opens, don't be afraid. Go ahead and have a seat. You may be surprised that the seat is warm. You might think a sumo wrestler was sitting on it. But the heat is actually generated by the built-in heater that warms the seat to an approximate body temperature.
Okay. So, a normal toilet starts uncomfortable, and you have to make it comfortable. With an electric toilet, it starts and stays comfortable, requiring little or no effort. If you have to use REST to build your UI, you have to write your own abstractions. You have to make assumptions about your API or APIs. It's very error-prone, and it's a lot of work to do. So like an electric toilet, starts out comfortable and stays comfortable, saves you a lot of effort. GraphQL starts out easy and should stay pretty much easy during the whole length of it. So for example, let's say we're using Apollo. It will completely handle your network layer, all queries, all mutations, all subscriptions, just some basic configuration. And this is a valid configuration, right? The reality is a little bit more complicated because you'll probably add auth headers, things like that, some middleware. But in essence, you just say, this is what I want to do, and the underlying logic gets handled for you. You don't have to implement all of that.
There is another function that you may find charming. Japanese women tend to become embarrassed when they are heard using the toilet. To be discreet, women would flush the toilet once to mask the noise, and then a second time to flush when finished. That is how Otohime came to be developed. The sound of a toilet flushing is emitted from a built-in speaker, so you only have to flush the toilet once.
Okay, well, I think that's kind of sexist, and I would totally use that feature. I think many men would. Regardless, it's a nice feature. It saves you embarrassment. It saves the environment. It saves water, right? And GraphQL, due to collocation and all-or-nothing loading, which we've talked about, makes it a lot easier to write more error-resistant code leading to less what I would call embarrassing production bugs. You know what's really embarrassing? Having UI components out of sync with each other. Let's say we have components A and B. They care about intersecting sets of data as represented by these queries. How do you keep them in sync? With REST, maybe you would use reframe, and maybe you would key both of these things by their primary key. And that would work, right? It would definitely work. But it's tedious, it's error-prone. And it's especially error-prone when you're dealing with references. So if these resources reference other resources or other lists of resources, it becomes pretty difficult to deal with. A GraphQL client, on the other hand, can automatically normalize all of your data and bind it to components for you. So components A and B are guaranteed to always show synchronized data. Even if something somewhere else changes in the app changes that data, they will both update at the same time with the same data. We also care about the environment. That's why we don't want to flush extra times. We don't want to waste water. So GraphQL can also help you with this, right? Like not with water specifically, but can help you with uploading data. So normally, you upload your whole queries, right? You upload whatever you're trying to send to the server. Persisted queries allow you to do that at build time instead of at runtime. So if we have this query, we're looking for, that we've seen before. We're looking for brands, we're looking for their names, we're looking for the models in those brands, and we're looking for the names there. At runtime, we would be sending this query. It's cut off the screen because, it's some long JSON thing. And the reality is queries are much bigger than this. To represent an entire UI of data, you have a large structure or sequence of queries. However, if we use persisted queries, what we do at runtime is this. That's all. We send an ID, a query ID, which we have generated at build time, and maybe we'll send variables, but that's all we do. Huge improvement for upload.
A whole set of buttons may make you wonder if you are in a cockpit. Each button is there to take you to a journey of safely and comfortably cleaning your rear.
Okay. If anything, I can attest that the real experience is much more thrilling than that video makes it out to be. So this toilet has remote. You request something, you get something. You don't get extra things that you didn't request. You don't not get the thing you request. You get exactly what you request. With REST, you have no control over that experience. You make requests and you just get some bundle of stuff back. Anyway, let's take a look at an example. So this is again the query that we're looking at before. To clarify exactly what this means, if we want the brand ID or like their headquarters city or anything like that, we don't get that here. If we want it, we have to add it. So we explicitly ask for exactly what we want. This drastically cuts down on the amount of data that you need to download. So this is another big improvement that you can have at runtime. You can also combine queries together, either using fragments or batched requests. And essentially what that means is that instead of having like your UI built with REST, where you want to do an initial load and you're fetching possibly dozens of requests, with GraphQL you fetch one thing, one request.
When you press the rear button, warm water will spray from a nozzle. The water sprayed from the nozzle is angled at 43 degrees, the optimal angle found after extensive research. There are also buttons like Soft and Pulsate for you to adjust the spray to your liking. From the first press of the buttons, you'll experience and enjoy Japanese innovation and hospitality.
Okay, so what more is there to say? I am curious about that extensive research on 43 degrees, though. Okay, so obviously this solves a problem. There's less manual cleanup necessary, right? Using REST, you're forced to clean up your own data and components. And like an electric toilet will clean up for you, so will a GraphQL client. Let's take a look at an example using optimistic mutations. So an optimistic mutation is when you simulate an instant successful mutation, giving the perception of a very performant UI, right? Like you do a thing, there's no loading, there's no server stuff, it's done, right? This is a difficult thing to do with REST, at least in a generic way. You need to build your own system for like reconciling data, updating it, binding it to components. You need to use that same thing consistently throughout your application. You also need to have an API which is consistent in terms of how it treats different things, right? In addition to all that, you need a way to update your components with the real data or the failure data when the optimistic mutation eventually succeeds or fails, right? With GraphQL, this is actually really easy. So when you mutate data, you can supply an optimistic response that the client will pretend is the real data and update all components that need that data. So once the real response comes back over the network, the GraphQL client will update the store and cause all watching components to re-render. If the data, only if the data is different, obviously. So React lets you offload UI rendering and cleanup, and GraphQL lets you offload data management and cleanup. They work pretty well together because of this. So you can push this complex, error-prone, application-specific logic into an open-source, uniform maintained library. And when your component unmounts, your GraphQL client will clean up, obviously all your queries that you're watching, all the subscriptions that you're watching, and any optimistic mutations that are relevant for that specific thing. So you don't need to do much. You don't need to get your hands dirty. Now, some of you might be thinking, why not just use reframe? I mean, it doesn't deal with optimistic mutations specifically, right? But it can certainly help with automating cleanup. So reframe and Redux are fine. They are. But locking is a totally fine way of dealing with concurrency and mutable objects, right? Like, it's a difficult problem, and locking is a reasonable solution to that problem. And that's what reframe is. It is a totally reasonable solution to the extremely difficult problems caused by using REST to build a UI. GraphQL is to REST as immutable data structures are to mutable data structures. So GraphQL is not a treatment, it is a cure. Now you might be thinking, reframe or Redux, it's so much more than remote data management. But I would challenge you a bit to think about that a bit further. In my experience, the vast majority of reframe code has to do with fetching remote data, updating remote data, updating local data that is in some way related, like derived from that or related to that remote data, synchronizing components with all of these different data sources. It's not all related to remote data, but a lot of it is. With all that said, nothing prevents you from using GraphQL in conjunction with reframe. This is a totally reasonable thing to do, especially if your app has a lot of local data, or if you're already using reframe and you want to slowly migrate over to GraphQL. There is a relatively new part of Apollo 2 and Relay Modern, which allows you to not have to do this for local data even. It allows GraphQL to deal with local data in the same way that it would with remote data. And it is awesome. It's called Schemastitching. Before I go into this, I would like to hit another little negative about this. GraphQL does not support namespaces, which is very annoying in general, and especially annoying with schema stitching, because schema stitching is where you take multiple different schemas and combine them, right? And if you don't have namespaces there, you have to understand, you either have to like programmatically namespace something, right, just to be safe, or you have to know what is in all of the schemas that you're combining to make sure you don't have any conflicts, right? So that's kind of annoying. But schema stitching is still super useful. So here's a query that we might have in a UI component where we're using schema stitching. In this query, we're saying, I want the current user, I want their name. That's all I want. This is persistent on the server side. I also want the device's color scheme, and as a note, this is persistent on the device, so maybe we have it in local storage or something like that. And I want the current page of the UI. This is client side as well, but it's transient, just in memory, right? What this is doing is it's allowing us to use a single interface to fetch data from as many different data sources as we want and get it all delivered at the same time with all the errors together. This is awesome. And this allows you to use Apollo or Relay to fully replace Redux or Reframe. So why not use something ClojureScript specific? Could you design a better toilet for your specific use cases? I'm going to go out on a limb and say yes, probably you could. But should you, right? Like the plumber won't know how to work with it. The building's pipes probably won't fit. Your guests are going to be totally confused. And you're probably going to run into regulatory issues. It's not worth it. The big reason to use GraphQL at this point, in my opinion, is the ecosystem. So GraphQL was initially released in 2015, but the ecosystem is already vast and growing very rapidly. If there's one reason for you to use GraphQL instead of something ClojureScript specific or something ad hoc, it's the ecosystem. The following languages have one or more GraphQL server or client libraries. Clojure, hooray. Elixir, Elm, Erlang, Go, Haskell, Java, JavaScript, Julia, Kotlin, Lua, .NET, OCaml, Perl, PHP, Python, R, Ruby, Rust, Scala, Swift. Side note, every other SVG converted to ping correctly except for PHP, which totally broke. It seemed appropriate to leave it broken. Anyway, let's say you want to learn about GraphQL. That's how to GraphQL. There are tutorials, front-end, back-end, multiple clients, multiple languages. You want a good client. You want to use React or React Native. That's Relay. Works incredibly performantly. Or you don't want to use React, or you don't care about performance as much and you need to work on iOS. You have Apollo client that works on React, Vue, Angular, Android, iOS, Ember, Meteor. Let's say you already have a REST API and you use Swagger. There you go, Swagger to GraphQL. You suddenly have a GraphQL API. It's not a good GraphQL API, but it is a GraphQL API. Or you're developing GraphQL API and you want to look at what's going on in your browser. There are Chrome extensions for that. Let's say you want to create doc strings or docs for your thing, GraphDoc, right? Easy. Let's say you want docs, but you want them to be dynamic, right? This is GraphQL Voyager. You can click through docs. You can dynamically understand your graphs. Or maybe you want to develop something in more of an IDE. That's what GraphiQL is for, right? This is from Facebook. Or maybe you don't like light-colored IDEs. That's what GraphQL Playground is for, which is basically GraphiQL, but with some more features and dark. There's also Altair, which is apparently like Postman for GraphiQL or for GraphQL. I haven't used it, but maybe it's good. Let's say you want something like JS Fiddle. That's Apollo Launchpad. You just server in your GraphQL server in your browser, right? Let's say you're using gRPC or any protobufs, right? Google wrote this. It's Rejoiner. It's just for you, right? It turns all this into a GraphQL API. Let's say you have a database and you want to turn that into a GraphQL API. That's what Prisma is for. just turns your database into a GraphQL API. You can even create your database schema using this. Let's say you're using Postgres. That's what PostGraphFile is for. It's something like Prisma, but maybe different. I don't know. Let's say you're actually using a graph database. Neo4j supports GraphQL in the database, right? It's a native part of the database. Let's say you don't want to worry about the backend at all. That's what GraphQL is. It's a backend as a service. You don't want to use GraphQL? That's fine. You can use Scaffold. That's another GraphQL backend as a service. You don't want to use a startup for your backend. You can use Amazon. They have a GraphQL backend as a service called AppSync. This is serverless GraphQL. You have SDKs for iOS, Android, and JavaScript that are based on Apollo. Let's say you don't want to deal with all the backend stuff. You just want a CMS. That's what GraphCMS is for. Let's say you don't want, purple. Well, this is kind of purple, but it's another GraphQL CMS. There's so much stuff. Okay, there's probably more between the time that I made this slide and now, and this is not everything. This is just like a little selection, right? So, what do we do from here? I think that the Clojure community needs to embrace GraphQL in the way that it has embraced React. We need to do that, I think, and we need to put a Clojure spin on it. So when you go to build your next application, instead of reaching for REST, consider reaching for GraphQL. Other things, if you're interested in doing projects on this, generating specs from GraphQL schemas would be super useful to validate and coerce both on the back end and the front end. Very, very useful. As a community, we could also really use a proper Apollo 2 or a Relay Modern wrapper. I've written a closed-sourced Apollo 1 wrapper and a Relay Classic wrapper, which are not really good, so are not going to be released. But if this is something you're interested in, talk to me. Maybe we can collaborate on it. Eventually, I think it would be great if we could have our own, fully ClojureScript client. There's no reason that we have to use Apollo or Relay. We can have a fully ClojureScript GraphQL client. Anyway. Okay, so GraphQL provides a much better experience than REST, and I really believe it's the way of the future when dealing with UIs, and I think that as a community, if we don't get ahead of it, we're going to be left behind. My hope is that you will join me in making GraphQL as ubiquitous in Clojure as electric toilets are in Japan. Thank you.
We're 2 minutes over time, but I think we can maybe take one question. Quickly.
How does it deal with authorization if you are not allowed to access certain data?
Very good question. So authorization is also not part of the GraphQL spec at all. This is another question that is left purely for developers. Also, HTTP is not part of it at all. So typically, we use HTTP in WebSockets, right? But that's not part of it. So what people typically do for auth is they send headers. Let's say you use JSON web tokens, right? You'll send a bearer header, right, with your requests. In terms of authorization of, if that's what you mean in terms of the actual API authorization, right? Or authentication, I suppose. Authorization of actual resources, you'll have some wrapper over your resolvers. So each resolver gets passed context, which is a global thing. So that's maybe like a connection to your database or databases. It might be, it's global stuff that you care about, right? It gets past arguments, which are specific to that field, and it gets past the parent, which is whatever was resolved before that thing. So another thing that can be in the context is who the current user is. That's an extremely common thing. And then you have logic which determines what can this user see, and should I return this thing? Or should I return some auth error?
Okay, once again, thank you.
Sure.
Coffee break. Come back at 4 if you're interested in the next talk. Thank you.